Hello, this is Mr. Stansbury. I'm going to take you through the notes on capacity. At the end of this, you should be able to say, I can find the capacity of various solids, and I can find missing measurements of solids given its capacity. Okay, so first thing, the capacity of a container is the quantity of fluid it can hold. Okay, so very similar to volume. All right, so what we want to do is volume to capacity. So 1 centimeter cubed, which is called 1 cubic centimeter, or you can also hear it often in the medical field as 1 cc, cubic centimeter, is equal to 1 milliliter. 1,000 cubic centimeters is equal to 1 liter. 1 cubic meter is a kiloliter, and 1 cubic meter is also considered to be 1,000 liters. So these are just some of our little conversion pieces here. Okay, so let's take a look at example 8. Find the volume of liquid which will fit into a container with capacity 340 milliliters. Okay, so here's our 1 milliliter. So that will be, that really is just going to be 340 cubic centimeters, right? Because that's what a milliliter is. Okay, 2.4 liters. Here's our liters. That's going to basically just multiply this thing here by 1,000 times 1,000. It's going to basically mean move the decimal over 1, 2, 3 spots. We get 2,400 centimeters cubed. Okay. 7,400 liters. If we look down here, we got 1,000 liters is 1 cubic meter. Okay, so if we take this and divide it by 1,000, so that would basically mean take the decimal, move over 1, 2, 3 spots. That is going to be 7.4 meters cubed. Okay, so these are all of our answers here. Okay, and then 7.4 kiloliters is going to be the same. A kiloliter is the same thing as a cubic meter, so that's just going to be 7.4 meters cubed. Okay? All right, example 9. Find the capacity of the tank. So really what we want to do is find the volume of the tank. So volume is going to be the area of the base times the height, right? And in this case, the base is a circle, so it's pi r squared times the height. So pi is pi. The radius of this thing is 7 squared times the height is 18. Okay, so now we'll just put that into our handy dandy graphing calculator, and away we go. So we got pi times 7 squared times 18, and that gives us, we're at 2771. Well, let's do 2770. So volume, actually it'd be 2771. And that is centimeters cubed, okay? But now since they're asking about capacity, this over here, this is capacity. And this here is volume. Okay, so we found the volume, so now we got to convert it into capacity. So it's centimeters cubed, so that's going to really be the same thing as, this would be 2771 milliliters. Or we could even turn it into 1,000. Let's see, 1,000 cubic centimeters is equal to a liter. So we divide that by 1,000, move the decimal over 1, 2, 3 spots. That would be 2.771 liters as well. Okay, so either one of those would work. All right, one last example, but before that, let's do a little comedy break.
I don't know who's writing books for babies, but I want a piece of that financial pie. I put my daughter on my lap with this big cardboard book, The Clock. The big clock. Tick-tock. The end. $12. And there's a synopsis on the back that is longer than the actual book, and I'm not exaggerating. Sit down with your children and you will delight as you read about the adventures of the ticking clock. Sometimes it goes tick and sometimes it goes talk, which just goes to show you never can be too sure in life, because sometimes things are one way, but they are about to change. Are you talking about this book?
All right. Let's see. Last example here. Example 10. 72 millimeters of rain falls on a 12 meter by 15 meter roof. All of the rain drains into a storage tank off to the side here that is 3 meters across and 2.5 meters tall. If the tank was empty to start, how many millimeters does the water level rise in the tank? Okay, so we've got to figure out the total, how much this thing's going to rise up this wall. Okay, so we know the base here, and I'm going to give you a hint right here. This 2.5, that is not going to help us at all. Oops, sorry, that's not going to help us at all in this problem. So we're just going to cross off that 2.5 because that's just telling you how tall the tank is. We're going to try to figure out how far up the wall of the tank the water is going to be. So it doesn't really matter how tall it is as long as it's tall enough to fit all the water. So first things first, let's figure out the amount of the volume of water that is going to be on this roof. Okay, so volume is going to be, we could call this the base here. So 15, I'm going to back up here a second. We got 15 meters by 12 meters by 72 millimeters. So fairly important piece of info here is that this is in millimeters and then these meters, meters, and meters. So what I want to do here is I'm going to turn this 72 millimeters into meters. So if you'll remember, we have King Henry died unexpectedly drinking chocolate milk, right? So we want to go from millimeters here back to meters. So we got to move the decimal over 1, 2, 3 spots to the left. So here's our decimal, 1, 2, 3 spots to the left. So that means the volume of this thing is going to be 15 meters by 12 meters. That could be our base. And then our height here is going to be 0.072 meters. And that will give us the volume of this whole thing in meters. Okay. So let's calculate that out here. We've got 15 times 12 times 0.072. Okay, so that gives us that we have a volume of 12.96 meters of water fell on that roof. Okay, and that is meters cubed, sorry. Now it all drained into this tank here, and we want to know how far up the wall that thing's going to be. So we know that the volume of this tank, the volume of the water in that tank is going to be the same as the volume that fell on the roof because it's all draining into the tank. So our volume of this tank is going to be the volume of the base, which is going to be pi r squared because it's a circle times the height, right? So we know the volume, 12.96. Pi is pi. Radius of this thing, if the diameter is 3, the radius is going to be half of that. So that's going to be 1.5 squared times the height. So we should be able to solve this thing to figure out what the height's going to be. 12.96 equals whatever we get for pi times 1.5 squared. So we've got pi times 1.5 squared gives us 7.068. I don't think I rounded that off, did I? I just chopped it off. So 7.068, and it goes, sorry, 0.068. Let's put a 6 on the end there. That makes it a little bit better. Times the height. Divide both sides by 7.0686. 7.0686. And then that will tell us what the height is, right? So we already have that 7.068 non-rounded in here. So we'll simply just do 12.96 divided by our second answer, divided by our answer here, and we get 1.833. right? 1.833, and that is everything we've done so far has been in meters, right? Now, if you'll notice, it says how many millimeters does the water level rise. So now we got to go from meters. We went from millimeters back to meters, so now we got to go from meters, 1, 2, 3, back to millimeters. So we got to move this decimal over 1, 2, 3 spots. So it's going to go up 1,833 millimeters will be how far the water goes up the side of the tank. Okay? All right. That's all we have for capacity. If you have any further questions at all on this, please feel free to ask in class. Thanks.